How are you all? I hope you all are fine. Okay. Last class I have given 3 problems as homework. Have you all finished? Okay. Last class we have learnt about imaginary powers of I. Do you remember? The value of root minus 1 is I and I squared value is minus 1. Okay. Today we are going to learn about general form of a complex number and organ plane and algebraic operations of complex number. Okay. First, last class I have explained complex number form x plus iy. This is the general form of a complex number. This complex number is denoted by z, where x and y are real numbers. This I is imaginary unit. Okay. Now some of the complex numbers, can you give some examples? S2 plus 3i, R4 plus 5i, are generally a plus ib, whatever. So this is real part. Real part of z is 2. Imaginary part is 3. Okay. So this is general form of a complex number. Next, equality of complex number. Equality of complex number is, suppose two complex numbers are equal means corresponding real parts and imaginary parts are equal. Now let us consider an example. X plus y on complex number is equal to some another complex number I4 or 4i. Now these two complex numbers are equal. So from this, how can we find x and y value? Yes, two complex numbers are equal means corresponding real parts are equal. Now what is the real part of this complex number? X. What is the real part of this complex number? 2. So x equal to 2. And imaginary part y, here imaginary part 4. So imaginary parts are equal. So the value of y is 4. So if two complex numbers are equal means we can equate corresponding real parts and corresponding imaginary parts. Next, algebraic operations of complex number. Algebraic operations. What is the basic algebraic symbols? Plus, minus, multiplication and division. These are the 4 arithmetic operations or basic algebraic operations. Okay, we can add any 2 real numbers, isn't it? 2 plus 3, 5, 3 minus 2, 1, 3 into 2, 6 and 3 divided by 2. So we can add any 2 real numbers, subtract and multiplication and division. Similarly, we can add any 2 complex numbers and any 2, we can subtract any 2 complex numbers. Similarly, we can multiply any 2 complex numbers and we can divide any 2 complex numbers. Okay. Now I am going to explain basic formula. Now I explained before that one more definition, organ plane. I think you have learned in previous classes real plane. Real plane is nothing but what? XY plane. Okay. Now you are going to learn organ plane. Okay. Organ plane. Organ plane. What is meant by organ plane? Now this is XY plane. No? This is x-axis, y-axis. This is origin. So this is 2-dimension plane or XY plane or real plane. So now in this organ plane, this x-axis is considered as real axis. Real axis. This y-axis is considered as imaginary axis. Okay. Now what is the general form of a complex number? X plus iy. So any complex number can be represented as an ordered for x comma y. Any complex number can be represented as an ordered for x comma y. Now see in 2-dimensional plane x, y. Suppose this is a point 1 comma 2. X-axis 1 unit, y-axis 2 units. So 1 comma 2 means where will come? Here. So this is 1 comma 2. So this is real plane. The same as, now consider 2i plus 3a. Sorry, 2 plus 3x. This is a complex number. I have told already, any complex number written as an ordered pair. Now what is the ordered form of this complex number? 2, 3. Now if we plot this complex number in this plane, we get organ diagram, or this plane is known as organ plane. Okay, now 2, 3. Here x axis 2, y axis 3 here. So this is organ plane. Okay, now I hope you all understood what is the general form of complex number, and equality of complex number, and algebraic operations, and organ plane. Now children, you have write all these things in your notebook. Okay, you copy down all this formulae and just you memorize this. So complex number is denoted by Z. Complex number is denoted by Z. Okay. Rectangular form of a complex number is Z equal to x plus iy. Rectangular form of a complex number is Z equal to x plus iy. What is the rectangular form of a complex number? Is Z equal to x plus iy. This is also known as general form of a complex number, where x and y are real numbers. What is x and y? X and y are real numbers. This x is called a real part. Okay, and this y is called an imaginary part. See, no I, only this number. This number is called a imaginary part. And symbolically we treat it as real of z. That means real part of this complex number. Real part of this complex number equal to x. And imaginary part of this complex number is what? Y. Now suppose if I give a 2 minus 3i. What is the real part? 2. Good. What is the imaginary part? 3. No. What is this? Minus 3. So imaginary part is minus 3. Okay. So this is basic concept. General form x plus iy. X is real part and y is imaginary part. Okay. Next, equality of a complex number. Equality of a complex number. Equality of complex number. Two complex numbers are said to be equal. Two complex numbers are said to be equal. See, consider first complex number. See, generally complex number is denoted by Z. See, two complex number, no, that's why we are writing Z1. This indicates first complex number. So, Z1 equal to x1 plus iy1 and Z2 equal to x2 plus iy2. These two complex numbers are said to be equal if and only if real part of Z1 equal to real part of Z2 and imaginary part of Z1 equal to imaginary part of Z2. See, what is if and only if? If you are seeing two complex numbers are equal means this is true. That means real parts and imaginary parts are equal. So here real part of this complex number, first complex number is x1. What is the real part of second complex number? x2. That is x1 equal to x2. Now what is the real part of imaginary part of this complex number? First complex number y1. Here y2. So y1 equal to y2. So now consider one example. X plus, already I explained x plus iy equal to 4 plus 5i means what is the value of x? 4. Why 4? Because it is given equal symbol. That means these two complex numbers are equal. So previously we have learnt if two complex numbers are equal means real parts are equal. That is why x is equal to 4. Then imaginary part y here 5. So y equal to 5. So the value of y is 5. Okay, next, any complex number z equal to x plus iy can be written as an ordered pair of real numbers x, y. So these are the basic concepts we are going to use in exercise problem. I hope you all will understand. So general form of a complex number is x plus iy. X and y are real part, and two complex numbers are equal means we can equate real numbers and imaginary numbers. Corresponding real numbers and imaginary number. Any complex number can be written as an ordered by x comma y. Okay. Now we are going to learn. We are going to see some problem based on this concept. Okay. Now exercise 2.2. 2.2 first exercise. 2.2 first one. Evaluate the following. Evaluate the following. Exercise 2.1. Evaluate the following. See, some problem is given. Exercise 2.2. Evaluate. See, given z equal to 5 minus 2i and w is equal to minus 1 plus 3i. Minus 1 plus 3i. Find first sum z plus w. Okay. See, here two complex numbers are given. To find z plus w. Z one complex number and w is another complex number. Now we are going to find sum of these two complex numbers, that is addition of these two complex numbers. Now z 5 minus 2i, z plus w. Solution, z plus w equal to z 5 minus 2i. What is the symbol here? Plus. W minus 1 plus 3i. Now we are going to add these two complex numbers. Already you have learnt in previous classes addition of two real numbers. Here you are going to learn about addition of two complex numbers. How can we add this? See, just if you want to add two complex numbers means first you have to add real numbers. You have to add real numbers or real part. Real part. What is the real part of this complex number? 5 plus what is the real part? Minus 1. So first you add this real part. Next imaginary part you have to add. What is the imaginary part of this complex number? Minus 2. What is the imaginary part of this complex number? Plus 3. So if you want to add or subtract, means you have to add the corresponding real parts and corresponding imaginary parts. Now this is the basic concept. Plus into minus, minus. So 5 minus 1 plus I into here minus 2 plus 3. Now this is generally what is? This is plus minus. Two symbols are different symbol. So put the greatest number sign. So if you subtract this 2, what will you get? Yes, 4. 4. Here plus sign. Here also two different sign. So because number sign is plus, if you subtract this 2, you will get 1. So equal to, this is 4, here 1. So what is this? 4 plus I. So the value of z plus w is equal to 4 plus I. That's all. So if we add two complex numbers, again we get a complex number. That's all. Okay. Next, second sum. Stop. Second.